how to convert an SDF file, a multiple SDF file, into PDBQT file for molecular docking. I'm going to show you the command line arguments that you can utilize to convert the SDF file into PDBQT file, and also MOL2 file into PDBQT files. So let's begin. So when you go to the database called ChEMBL or Zinc database, you have the option to search for different types of structures, the drug compounds. So I'm going to show you one example how to download the structure from ChEMBL and also from the Zinc database, and how you convert the SDF file or the MOL2 file that you obtain from these two databases into PDBQT format. So first of all, if you go here, there are 14k drugs in this particular database. So I like this database because it's pretty it contains a lot of information regarding the publications, the molecular weight, and you can categorize these chemical structures into different Lipinski rule of 5 or Lipinski rule of 3 as well, and you can categorize the drugs. So if you go here and click on 14k drugs, so you have something around 14,293 records. That means these many structures are there, and you are interested. Suppose I am interested in the small molecule, so I go to small molecule and click here, and it will be reduced to 10,987 records, chemical structures. If you go further below, so you need these are the phases, the clinical phase trials, that is 0, 1, 2, 3, 4. Suppose I need 4th clinical stage. Okay, and RO5, this is a Lipinski rule of 5 violations. Suppose I don't require maximum violations, but if there are 4 violations, that means 4 of the categories or 4 of the criteria are not validated in this case. Suppose I need 0 violations, no violations at all, and the molecular weight would be between 500 molecular weight. It should be below 500. So I need 0 violations, RO5 violations, and I need molecular weight somewhere between, suppose, 50 to 90. Okay, I'm just taking it for example. And you can choose A log P as well. And also, if I'm looking for any particular disease type, like any cardiovascular system or dermatology or anything, whichever is required for your analysis purpose, that you can choose from here. Suppose now how many molecules we have? We have 25 records. Okay, let's go and download this by clicking here SDF. Okay, and you click on select all. All the drugs have been selected. Now you go to the SDF button and click here SDF. So the process will begin soon. Here there will be a progress bar, and let's see if we can download. Yes, you can see that you can also check the progress here. So it generates a SDF file from the search. Okay, so now it says generating downloaded file 100%. Soon you will see click here to download the file. Okay, just click here. Then you have this particular name with it. So if you go to rename, so this is a coding from the ChEMBL database. You can keep as it is, or you can change it based on your name. Okay, I have already downloaded some of the molecules which I am targeting basically. So you can follow the same procedure with lot many based on your needs. Okay, so I'm going to copy this. This is a 5 molecule SDF file. It contains only 5 molecules, but this contains almost around 25 molecules. So I'm going to take this. You can do the same for as many as you want. People use more molecules, like 10,000 molecules or 1 million molecules. They can go for that, but the coding to convert the SDF to PDBQT is the same. So I'm going to use this, and let's see. Yeah, I'm going to paste it over here. Now what you can do is, so I'm going to open the command line. Let me make it a little bit bigger. Now, so this is your multi SDF file. It contains all the 5 molecules. Okay, the first command that you require, and yes, of course, I forgot to mention that you need to use this particular command line called OBabel or Babel. You can install it via Conda, and also you can install it from the Windows operating system as well. Okay, so pretty straightforward. If you go to OBabel install from the Anaconda database, you can install it, and I think for both Windows, Linux and Mac users, they can use it. And I think, yeah, it's pretty straightforward to download OpenBabel and install it on your operating system. Okay, for the Mac and Linux users, so I recommend everyone to install any of the softwares which requires command line to use Anaconda. Anaconda is the best. Okay, if you search for OpenBabel Anaconda, so here you can see the command for this is very simple: conda install -c conda -first OpenBabel. That's it, and you get the version of OpenBabel. Okay, so let's go to the command line, and if you type in OpenBabel -h, you get all the different options. This is the README documentation of OpenBabel. You can go to this website as well, which contains all the command line, how to convert multiple formats from SDF to PDBQT, MOL2 to PDBQT, PDB, XYZ, etc. Okay, to make it a little bit bigger. Okay, I'm going to clear it out. So first thing what you want to do is you have to split this molecule. It contains 5 molecules, so if you split this, so it will be named as 1, 2, 3, 4, 5. So the first command will be OBabel and your file name, that is the big file name, okay, capital O, and you want to name it. Suppose you need the files in drug 1, drug 2, drug 3, drug 4 and drug 5. So what you have to give is drug, this is the file name extension, .sdf, okay, and -m. M is for multiple operation. Okay, if you click enter, you will see that 5 molecules converted, 5 files output. The first one is drug1.sdf. Since you give drug.sdf, so it will be categorized as drug 1, drug 2, drug 3, drug 4 and drug 5. Okay, now you have all the SDF file. If you open this using Avogadro, you will see that it does not contain any 3D coordinates, no. And you will see this is the 2D format of that particular chemical structure. Okay, and this 2D format is not gonna help you in your molecular docking approach. You need 3D coordinates for this for these chemical structures. Okay, so what you have to do, the next command is you have to add hydrogens. Basically when you convert all these molecules and apply for molecular docking, you need to add hydrogens. Hydrogens play a crucial role in molecular docking Okay, to add hydrogens, what you have to do is, this is your original file, just keep it somewhere or just delete it. You have already downloaded it, so you just have to delete this, and you now have all the files 1, 2, 3, 4, 5. So these are the files which you require. Okay, so now using a for loop, this is a simple bash command for I in star.sdf. Star.sdf means your SDF extension. Okay, colon do OBabel $i means your SDF files, drug1, drug2, drug3, and the star means all your file names such as drug1, drug2, drug3, and .sdf means the extension. Okay, $i means this one is using it. So this is basically the for loop operation. Okay, and -o. Okay, then $i, because you need the same file added to it. You know, the hydrogens should be added to the same file. You don't need other files to be created. So $i. Okay, and -h. -h is for adding hydrogens. Okay, now colon and then done. So if you click enter, you will see that one molecule has been converted. If you go here, previously there were no hydrogens, but you can see that hydrogens will be added specifically to these chemical structures. Okay, the next thing that you require is to generate the 3D coordinates. So the 3D coordinates will follow the same command, but what you need to do is just type in instead of -h, just type in gen3d. Okay, gen3d is the command for generation of 3D structure, and click enter. You will see that one molecule will be converted, second molecule is going to be converted, but the stereochemistry is wrong, and OpenBabel uses a distance geometry method in order to convert all these molecules into 3D structure. Sometimes the stereochemistry is wrong, because the 2D structure, when you try to convert into 3D structures, sometimes the stereochemistry gets a little bit messy. So OpenBabel has inbuilt algorithm which uses this distance geometry based method in which it can correct. So previously it was 2D format, but if you click and open using Avogadro, you can see now the 3D coordinate. Now it has been converted from 2D to the 3D coordinates. Okay, so this is how you convert 2D from the 3D. It will take some time. So in the meantime, what I'm going to show you is this zinc database, how you can use this zinc database for searching for molecules. So if you go to the substance section, okay, and I want to there are options over here. So if you type in the name of that particular molecule, and if it doesn't show up, suppose I type in remdesivir, okay, you see that there are no result found. So what you have to do is you have to go to the PubChem database and go to the canonical smiles, okay, and copy this canonical smiles and paste it over here. Now you can see the structure of remdesivir. Okay, and if you want similar molecules which is similar 40% similar to this particular molecule, then you type in similarity 40% and it will search all the molecules which are similar to remdesivir. 1.0 means it is exactly similar to remdesivir. 0.88 means 88% similar to remdesivir molecule. So in this way, I mean, it depends on your interest what molecules you require, and if you need a bigger database, there is another link which I can show you over here. You can download 1 million and 1 billion compounds from zinc database and you can utilize for docking. For now, if you are searching for remdesivir and 40% similarity, then go to this option, download. Do not download the SDF format. Instead, there is a format called MOL2. So if you download the MOL2 format, that means it contains all the charges and it is already converted to 3D. So you don't need to convert from SDF to PDBQT or MOL2. So just type in MOL2 and all the molecules will be added. All the substances will be downloaded using in MOL2 format. Okay. So let's go and check. Yes, now everything is converted from SDF 2D SDF to 3D SDF. Okay. The next thing what you want to do is you want to minimize these molecules. So OpenBabel has inbuilt algorithm to minimize these molecules. So for that, what you need to do is you need to paste in for I in the same for loop, and the command is ob minimize -ff. This is the molecular force field. Okay, and you can give any number of steps. Suppose I give 5,000 number of steps and $i. Okay, just click enter and you will see that it is getting minimized. So all the 5 molecules have been minimized and it took only 0.18 seconds. Okay, so it's pretty fast because these are small molecules. Okay, now you have minimized all your molecules. Now what you want to do is, if you are converting from SDF to PDBQT, the first thing that you require is to convert into MOL2 and then convert into PDBQT file. So for that, what you need to do is, the command is first convert into MOL2, that is OBabel star.sdf, means all the SDF files, -o MOL2, okay, then -m. So if you enter, and you will see that all the molecules have been converted to MOL2 format. And if you click on MOL2 format has one good option. As I mentioned before in my tutorial, they have charges. If you convert into PDB, they don't have any charges. So for chemical structures, I recommend everyone to convert into MOL2, which contains all the charge of different atoms. Okay. The next thing that you want to do is you have to convert these MOL2 files into PDBQT format. The command is same, just type in here star.mol2 and -o PDBQT -m for splitting. So if you click enter, you will see that all your molecules have been converted into PDBQT file. So if you open it by Chimera X, you will see, yeah, this is your 3D converted molecule from SDF 2D SDF to 3D converted chemical structure, which is already minimized, which is the best option to minimize any chemical structure. Or else what you can do is you go to drug1.sdf, the SDF format, and then go to extension and then optimize geometry. This option you can utilize and then save one by one. So rather than that, you just use the command line, which is really simple, and you can minimize n number of steps for any molecule and then save it as a PDBQT file. So now these files, PDBQT files, can be utilized directly for molecular docking analysis. Okay, so this is how you convert. Okay, so let me go to the Zinc database. Let me go to the Zinc database. So I have downloaded this particular file. So let me see. Yeah, this substance.mol2 and paste it here. So now you have the substance.mol2 file. So now what you can do is go to the directory, and the command is very simple because it is already in MOL2 format, that means 3D format. What you have to do is you just have to convert this into PDBQT. But before that, you have to split this molecule. So for splitting, OBabel substances.mol2, okay, -o Suppose you name it as drug.mol2 -m, and you see it is converted to drug 1, drug 2, drug 3, drug 5. So you delete this file, you don't need this, and you can minimize it, of course, but I think it is already minimized and it contains 3D coordinates. But if you want to minimize it, then you just type in the command for this. Instead of SDF, you just type in MOL2. Okay, and it will be done. It's minimized. Okay, so the next thing that you want to do is you have to convert this MOL2 to PDBQT. So the command is pretty simple: OpenBabel MOL2 O PDBQT -m, and that's it. Your drug 1, drug 2, drug 3, drug 4, and drug 5, everything is converted. Yeah, so this is how you can convert any molecule from 2D coordinates to 3D coordinates. And yes, I mentioned you about downloading the whole database for molecular docking. So if you go to this website zinc12.docking.org, browse subsets, you can find all the clean ligands or clean leads, and you can download all these molecules for molecular docking approach. Yeah, that's it for today, and I'm going to paste all the commands in the description, and you can utilize these commands for converting the molecules from SDF to any format you like: PDB, XYZ, MOL2, SDF, etc. So thank you very much, and I thank to all my subscribers that you're liking my videos, and please continue viewing my videos and liking my videos, and please subscribe to my channel. Thank you very much.